Right. Well, welcome everyone. We're really thrilled tonight to have Professor Elaine Cheng from Laurier joining us to talk. And just before I turn the floor over to her, I'd like to begin with our land acknowledgement. So the Grand River chapter acknowledges that much of our work takes place on the traditional territory of the Attawandaron, Anishinaabeg, and Haudenosaunee peoples. Our chapter is situated on the Haldeman Tract. That's the land granted to the Six Nations that includes 6 miles on either side of the Grand River. And our active work toward reconciliation takes place through research, teaching, learning, and community building, and is centralized within our main body, which is now located in London, Ontario. And just a few remarks, if I could, about our speaker. Dr. Cheng received her PhD in anthropology from the University of Toronto in 2024, and her MSc at University College London in 2012. Prior to completing her PhD, Dr. Cheng worked in the cultural resource management sector as a field archaeologist. I believe it was ASI, wasn't it, Elaine, where I also worked? But I think you also worked for OHT,
Yes.
which we can classify as CRM too. So she worked as a field archaeologist, a lab technician, artifact analyst, and a field director. The focus of Dr. Cheng's research is material science, specifically mineral analysis and chemical composition analysis of pottery and metal. She's interested in reconstructing the techniques, skills, organization, and knowledge of past artisans. And currently, Dr. Cheng's area of study includes both Ontario and local wares from Ontario and European ceramic technology, as well as Chinese Shang Dynasty bronze casting. So with that, I'll turn it over to our guest for this evening, Dr. Cheng.
Great. Thank you so much, Chris, for this wonderful introduction, but also the invitation. Thank you, Chris, and the Grand River chapter for having me here to share my research and kind of just talk about some of the things that I've been looking at. So my research is, title is From Ontario to China and Back Again. But really, even though I covered a lot of, I guess, distance, most of what I'm looking at is on the artisans. And I'm going to kind of explain why I find this significant and absolutely fascinating. Um, okay. So the presentation outline is going to focus on the introduction, background. I'm going to touch up on the methodology. Result, we're going to talk about kind of the Wendat pottery production and the Shang Dynasty bronze casting mold production with the focus on the artisan specifically, then discussion and conclusion. So the introduction. This research uses scientific archaeology and the application of artisan theory to better comprehend the past and learn from the ancient artisans. Artisans like the Wendat potters, Shang Dynasty bronze casting mold artisans as well, and we'll kind of talk about them in different scenarios and different kind of even all within the use of scientific archaeology. But a lot of people have asked before, why is ancient artisans important? Really, for the ancient artisans were the individuals who created the material culture that we as archaeologists study. So they were the individuals who converted their natural world to their cultural world. And without them, we cannot comprehend the past the way we do in archaeology. So having them kind of in this this production and creating these artifacts or objects, we are really very much looking at what they've literally created and left behind. So when we look at, so we have to look at, well, beyond the artifacts. The artisans were kind of the center of the artifact production. And when I talk about artisans, what I mean by artisans is anyone who created objects. not limited to the raw material, not limited to their social status, but individuals who were masters in their own craft and or even apprentices, right? These were the individuals who used their hands and knowledge to produce the material culture we see today. They did not only produce the objects we see, but they are actually connecting three major spheres. We have the technological sphere, which is in the kind of the yellow circle up top. What this is their knowledge, their know-how, their ingenuity as well. And that knowledge of technology actually crosses the two other spheres. Geography being one, where the raw material was found, how and the choices that the artisans made to utilize these materials, right? There's multiple ways to produce anything. They made and decided and chose these specific ways to portray their culture. Technology, again, also overlaps with consumers. Without the consumers, without the culture that wants these objects and uses these objects, we're probably not going to see a lot of them and see it in such density as well. So the and often this overlap can result in things like the vessel forms, the motif type, and to name a few. Of course, the artisan also encompasses geography and consumers, where the raw materials were and where the consumers were can also reflect their view and their actually knowledge and use of the land. So the artisans were essentially very central to all of the artifacts we see today. So my method in analyzing the archaeological materials, I focus on ceramics. Ceramics either with high clay and or high silt material. And this is ideal for using petrographic analysis. Petrographic analysis is the method often used for ceramics, but you cut kind of thin sections of the artifacts into 30 micron thick slides. And we often look at it through an optical microscope, as you can see in the image to your right. This first image on the left is actually the kind of raw material of the Damiani ceramic, ceramic type. And you can see how they have, well, I'm sure a lot of you are very familiar with this type of material, but you can see kind of the coarse temper that's involved, that's included, as well as the clay. These other two images are actually from the Sung Dynasty bronze casting molds. And you may have noticed that well, they look quite different in size and in the the content. There's very little clay. There is abundance in minerals. Some of them actually have shell and calcium present, which again, we're looking at, just by looking at these three images, we're already seeing, well, different choices. We're also seeing different geography and even use, right? But what is particularly important here, and when we use things like photography, is that we're not just trying to get data, and we're not just trying, I mean, we are, sorry, we are getting data. However, the data that we're getting and reflecting is trying to understand the artisans and or the society in the past. So scanning electron microscope is another uh, tool that I use for analyzing these ceramics. One is I use scanning electron microscope to look at the microstructure of the materials, such as this one over here, which is the different silt-sized minerals that you can see. and I will show you kind of other images as well, and to look at the chemical composition analysis of these raw materials to give us an idea of the grouping of the chemicals, of the different artifacts and materials. But scanning electron microscope actually has a very, it has an advantage in looking at artifacts because unlike X-ray fluorescent, not the portable, the actual X-ray fluorescent, INAA, a lot of these samples needs to be crushed. And even though we can look at higher percentages of more various elements, for a lot of these materials, looking at the materials in situ is actually much stronger in, well, showing us what the choices and the decisions were made and how these artifacts or raw materials were found on the landscape. So when we talk about material science and technology and archaeology, we do have a tendency as scientific archaeologists, we do have a tendency to look at kind of artifact production in this way, where this flow chart, the sequence of production, the original raw material, the how the raw material was processed. This is a sequence of production of a bronze casting of a bronze vessel. So even with a more complex sequence of production, we're separating the bronze with the casting mold. We're still only seeing how different materials transition from one state to another. And I think, a lot of coupling this with artisan theory, we can go beyond the sequence of production to see the artisans, right? To see the knowledge. Again, what, how much did they understand the materials they're using? Did they apply these materials? And I'm not, one thing I want to really, really drive home is that I don't think for us archaeologists, we probably shouldn't be the ones judging if they were successful or not. And we probably shouldn't be the ones to say, well, they're using the wrong material. Because they're the ones, they are the masters. They are able to create, and these two materials that I'm talking about right now today, not a lot of people have been able to replicate it exactly like how these artisans did in the past. Um, in in a lot of ways too, and we'll talk about that. But in a lot of ways, not a lot of artisans today will use silt. If you look up silt on in Google or the what you can use is generally not for ceramic. The clay tend to be the preferred raw material for today's artisans, right? And same as the Damiani pottery, which illite, and I'll kind of go into that a little more, but illite is raw material, the clay that was preferred. If you again look up illite, even in engineering uh, discussions, illite is generally viewed as clay that is not ideal for pottery. And yet, they were able to create these beautiful, gigantic vessels with the knowledge and the interaction between themselves and nature and the choices that they made, the things that they've learned, which is very, very important, but also substantial. So, what I'm kind of saying here is that I think as archaeologists, it's been wonderful to kind of learn from these ancient masters. So really, really, what we I would like to look at is kind of the knowledge transmission, right? How did these objects, how were they made for hundreds of years? Were they were they made the exact same way? Or were they made differently? And what does that mean? Or what does that say about these artisans and their organization? And different organizations, different objects can be organized in many different ways as well. So we're gonna kind of go into this and talk about it as well. So really, the artisans are the connection between the production to the culture and the landscape. So we're going to try and look beyond this flow chart. I mean, this flow chart is still important and still very much relevant in our understanding, but um, let's try to go beyond that. So first is the Damiani site. Damiani site is the Wendat village site located in Vaughan, Toronto. It was dated to AD 1450 to 1500. So 150 years of occupation, and it was excavated in 2008 and 2009. Now, as I mentioned before, the clay was Illite's clay. Illite clay is not a ideal clay for modern pottery production. As you can see from, sorry, the it's a little blurry, but the green triangle and the blue circle, they're all juvenile vessels, and there's 4 sampled, and the black and the red squares are adult. They all fall within kind of the illite clay sample area, and there's no distinct variation between um, adult and juvenile clay. What is interesting and important actually when we look at this is that this flow chart is very I'm just gonna kind of go through this flow chart, but the clay was refined, right? The temper was processed. The temper most likely came from fire-cracked rocks from the site. There's still further analysis that's being done currently for my research that I'm trying to find the most likely sources as well. But the temper processing, you have, even though if it's fire-cracked rock, it still has to be cracked and it still has to be processed and broken into finer grain. As you can see in this bottom sample, this is a temper, and this was taken at 200 times the magnification, but this indicate a conglomerate of different minerals. So they weren't just using sand that was weathered and broke down naturally. They were using rock and minerals that was actually combined, which makes it fascinating to look at petrographically because usually like you can actually see kind of the likely original kind of mineralogy as well as the likely rocks as well. But to go through that, the clay was refined, the temper has to be processed. There was certainly thought. Now, they both have to be mixed and combined. Now, what is interesting with the forming too is that when we look at forming, this picture on the left is an image from the scanning electron microscope. This is a natural, kind of a natural break of the ceramic. What is indicating is that there is no real striations in compared to the exterior and interior surface of the pottery. Well, this one, you can see these kind of cracks that goes throughout the fabric. And this is actually running right parallel to the interior and exterior of the surface. Now you might be saying, okay, well, we are seeing some microstructural alterations to the pottery through paddle and anvil techniques. We're seeing that, they're applying so much force that we're actually seeing it microscopically. Um, the other interesting thing too is that with the forming, most juvenile vessels, their breaks has no real, well, paddle and anvil technique likely, or they don't have the strength, right? In order to do this, you might require a lot more strength to force the clay and to get the clay to form in this way. So we're seeing in within Damiani, there's two different production forming methods. And according to the Jesuit relations, a lot of the records indicate that they used to create pottery from putting a fist in the middle of the clay and then creating, forming, and expanding it in that way. Now, think, and we'll kind of talk about the juveniles in a bit, but the juveniles were, even if the children were trying to learn the exact same way, they may not be able to produce the exact same patterns within the artifacts, especially not, I mean, strength for one, but also their kind of motor skills were may not have gotten there yet, right? And I'm not going to say, you know, what age, or this is not within um, my study, but to see that kind of change in the forming technique is indicative of some kind of variation as well. Now, firing. Firing tend to be upside down. Vessels, we have open fire as well. But the firing, what's interesting between the juvenile and the adult vessels, is that the firing actually is consistent. Firing temperature wise and the firing method tend to be the same. Again, though juvenile vessels, they don't tend to be found in such a as regular of a firing atmosphere in some cases as the adult vessels, but there is firing. The reason I'm kind of talking about firing in this way is that, well, considering a potter and an apprentice or a child learning how to make a vessel, the firing most likely may have occurred with the adult potter. Um, but again, we'll kind of, and the last is use. And the use of the vessels directly goes back into that cycle of understanding the clay, understanding the temper, understanding the purpose of this entire sequence, right? And why they're mixing these two materials together. If they have not thought about what these vessels were required, well, the production might not have been very successful. And again, we might not be seeing as much of the vessels as we are, right? So these things are absolutely fascinating, but absolutely connected as well. So juvenile vessels, I've kind of mentioned, and they're less than 5 centimeters diameter, crudely made. Again, they lacked paddle and anvil void orientation. There's no orientation whatsoever. We're actually seeing kind of little air pockets throughout as well, which the adult vessels also have these air pockets, but it's not aligned at all. These voids were not fully aligned. Um, and what is Well, what is also fascinating is that we have possibly intermittent production where the the child was creating these vessels with actually good raw material. Good raw material, these raw materials were actually the same raw material, meaning that raw materials in this way were probably unlikely created by a child. If anybody are there's if there's any potters in the audience, you may, or if you've ever tempered clay, you may realize how difficult that is. It requires a lot of upper arm strength, depending on the culture. I mean, thinking of kneading dough, right? Having a child knead dough is completely different from adult. A lot of cultures even, we stamp on the clay, they employ mules. Like these are labor intensive activities. And yet they were also given to the child to use and to create their vessels. So it's not just, you know, um, it's not just saying they were learning, but they're actively a part of that community. They're not just sitting on the sidelines watching and copying, but they're actually given these raw materials um, to use and to play, or to try and recreate what the adults were creating. So again, same raw materials. We're seeing that, and the mixing of it. It's not if the clay was not well mixed, um, there would be some issues during firing. So with that being an issue, we can have some, you know, they were able to fire these juvenile vessels, not because they happened to be in the right fire and they were just kind of they were actually using the right materials to fire the that is fire that can be fired and can possibly be successful for the end product. So, we kind of talked about the Damiani site, and what I thought Damiani site was absolutely fascinating and absolutely interesting is that we're seeing knowledge transition. We're seeing, well, knowledge transition in the way of children and a master, their interaction in a way to learn vessel production. Anyang site is quite different. Anyang site is in found in Henan, China. It's a late Song Dynasty capital, and it's dated to 1350 to 1046 BC. Um, it's been under excavation since 1928, and it's a UNESCO World Heritage Site. Now, this is the Anyang site boundary, and Huanbei is an earlier site, has not really been occupied during that time. But what is interesting is that these orange dots were the bronze casting foundries found in the Anyang site. And these blue circles are what the Anyang archaeologists would organize them as um, workshop areas. And they group them according to kind of the location within the larger city sites. So bronze casting vessels, giving you a kind of an idea of what this is that um, bronze casting vessels was cast in the late Song Dynasty, and it was used by the elites. Um, it was used by the elites, and the casting molds that I look at is on these kind of the exterior casting molds, even though they're piece molds that may constitute a few pieces, four, six, various pieces that is assembled together and cast. So the middle is the bronze, and this would be the interior cavity of the vessel. Well, this is the motif as well, and the little legs would have fit in the bottom. They would have holes on the bottom for pouring the molten bronze into the cavity and allowing air to escape. Like so. And this connection, they're put together. This is the cavity that will create the vessel, and you pour, again, the molten bronze. Now, to create a vessel, like so. Now, what is important here is that the artisans who made the bronze casting technology must be aware of the purpose of this material and the purpose of this production. Um, to create the bronze casting molds, um, they were not just creating it um, as a vessel like those of the Damiani site. They were actually creating it as tools to create their final object. And the bronze casting molds, after their casting, they were actually broken down, removed, and discarded. So for the bronze casting molds, artisans, for Anyang site, a site with now I think there is 9 workshops discovered. Uh, there there's only 2 casting mold types. One is type 1 over here on the left, and type 2 on the right. You have and they're actually made out of silt. Silt in general is not viewed as a ideal raw material, but also silt is a very difficult material to use. Um, I don't know if, I guess this is a harder one to say if anybody had experience working with silt, but think of trying to get sand, wet sand to form. You can make sand castles with it, um, but to make the intricate designs to kind of push the mold into um, a decoration, it is actually very difficult. And so again, then why were they using this material? Um, One of the reasoning from the Anyang archaeologists and Chinese archaeologists research is that this material actually allows for air ventilation. Because clay would have trapped any of the air that's formed within the cavity. And what would happen is you would have failed casting. The bronze would not have gone all the way down, then you would have to break it, recast, and so forth. So silt actually allows for the casting as well. And it is an absolutely ideal material, even though it's hard to work with. And I'm saying hard to work with modern experiences, with kind of my experiences only with clay. Um, but it is actually an really good material to kind of um, retain these decorations over here. Um, so when they use the silt material, you see this kind of very, very dense kind of silt. They actually did not just use one raw material within one casting mold set. Some casting molds, especially the type 2 casting molds, actually had the 2 different raw materials combined and compressed into one. Um, Now, the reasoning for this was likely for support of the casting mold as you assemble the piece mold. But the other thing is these this raw material was actually very much unrefined. There you can find shelled, you can find some organic material. The ranges from silt all the way to sand size material, and you have a kind of an all it looks more kind of jumble together. So a lot of the questions then become, where did the raw material come from? Now, the very fine silt, the kind of famous Loess plains, were found on the western side of the Taihang Mountain. However, Anyang is on the side and on the east side of the mountain, and it would have to, well, it's about 700 kilometers away to bring silt, refined silt, into the area. So, but then, well, I mean, they were also sitting on a floodplain. This floodplain is where Yellow River, sorry, I'm gonna go back. Yellow River comes into, and it kind of washes through the Lewis Plain and comes in, brings the silt and mixed material in. So what actually was fascinating about this as well is that the raw material, that the unrefined raw material that was used to mainly support the structure, probably decrease the cost of creating these casting molds, were likely found in Anyang itself. But comparing between the raw materials, we have these silt size material, the fine silt, refined silt, that is only found on the casting surface, while these kind of the unrefined silt is found on the external surface. But if you look at the kind of the graph, actually, um, this looks very different, right? The percentage, the amount of raw material, of clay sized to silt sized, and a little bit, and oh, sorry, clay size to silt size, and no sand for the fine fabric, while the fabric two had a combination of all three. From petrographic analysis and measuring and comparing these materials, if you remove these these two sized grains, you actually have a very, very similar curve within the same casting molds. So they were actually refining local material to produce the fine casting mold surfaces, like so. So once this is removed, I change the percentage, or recalculate the percentage, and you can see that it's starting to look like similar. However, we still have rutile. Amphibole is here as well, where it's missing from from the fabric one, and there's far more carbonate. What's actually really cool here as well and interesting is that the carbonate, amphibole, and rutile are actually heavy minerals. To process, you would have to remove it through gravitational separation. Things like fluvial separation would be one of the main ideal methods with the way the raw material is presented. So mold type 1 and mold type 2, they were both, they used the same silt, with very different forming methods, different processing, um, and though similar firing, casting, and discard. In the larger context, what we're actually seeing, what we're actually seeing is that fabric 1 was used by both type 1 and type 2 molds, while fabric 2 is only found in type 2 molds. However, the forming method is quite different. The type 1 mold had smooth with ribbed edges, and kind of thin exterior motifs, shallow compression, incisions on the center, and stamping as well. Because actually how thin it is, through experimentation, it is, well, through experimentation, if you put too much pressure on it, it will actually break, and while you're forming it. Type 2, there's a lot of compressions on the exterior surface. There's layering. You see mortise and tenons on the edges. Interior motifs where there's deep compression and incisions as well. How they're dried, we unfortunately don't know, but for type 2, we do know that they were dried as a full set. And that ensures that this set can dry equally so that they're not warping and at the end, so we can't use it for casting. They're fired in reducing atmosphere, and they're cast in open firing with modeled atmosphere on exterior surface, reducing atmosphere on the interior surface through casting. And then they were discarded. But what's interesting is that there's combinations of shared knowledge and there's divergence of separated production and separated um, forming methods, even though, and they have similar, if not raw material, share knowledge in raw material use. There is actually only two bronze casting mold production sites in the entire Anyang capital. And it's indicative that, well, there's further specialization within the bronze casting artisans. And these orange dots are actually indicative of bronze casting that occurred, while these circles, they're the only two bronze casting mold production sites that has been found today. So we're seeing kind of further separation between the two casting molds, but we're also seeing further separation on the larger landscape. Now, there there is a lack of indication where Xiaomingtun site and Miaopu site were where type 1 was only produced there, while Miaopu was type 2 was produced there. That's actually not the case. What's fascinating again is that the production of one is found in both sites. And then type 2 took over and then were again found in both sites. So indicating even within the city, they're still sharing knowledge. They're still collaborating. And there is definitely specialization and kind of working together. So learning from the ancient masters has been I mean, it's still ongoing. It's still very absolutely fascinating. And I personally feel like an apprentice that doesn't get the masters to tell me what it is, and it's sometimes very frustrating. Um, but kind of, I think for archaeologists, like, all of us, really understanding their knowledge, right? Even though, yes, they're, a lot of some of they're gone, but their knowledge, their comprehension of the specific steps involved in producing the artifacts can really, really help us in understanding more about not so much who they are, but how the materials came to be, but also why and their kind of knowledge for sure, and how they understood these raw materials. What the artisans must comprehend, again, to transition from one step to another, from the artifacts to be produced in that specific way, right? Like I mentioned before, artifacts can be made in various different methods. They chose this one specific method. And what's absolutely fascinating too is they chose to, well, some masters chose to transition this knowledge down the exact same way through different generations, while others decided not to, which I know I don't really have time to kind of go into this, but it goes into kind of learning and kind of, I'll kind of talk about knowledge transfer a little bit. But knowledge transfer, again, looking at artifacts as a manifestation of ancient knowledge and shifting the discussion to the ingenuity of the artisans from the various cultures who made the artifacts. And this time we're looking at how the production changed through time, right? I mean, some of these, so Anyang site was occupied for 200 years. Damiani site was occupied for 150 years. I mean, it's possible that, well, okay, you know, um, for this production to continue within the village, within the capital, it's not just one artisan creating this over 200 years or 150 years. They must have passed down this type of production method and this knowledge to the future generation in order for us to see it through such a long stretch of time. So seeing the artifacts in the context of the past, again, by focusing on the group of individuals who made them, actually, I think can help us better understand and, well, also better appreciate these artifacts and its production and the artisans as well. And organization, how the artisans work together to produce the artifacts, were the individual steps of the production separated by specific groups or artisans, right? Were they organized in specific ways? And again, organization can occur in multiple different ways. And it can be dependent on various factors as well. So organization itself can also create kind of further understanding of the past. So in conclusion, artisans bridge their environment, culture, and knowledge to produce the artifacts that represented their cultures. Again, far more than artifacts, but kind of bridging at the various aspects of the ancient culture and contextualize it kind of in the form of their everyday artifacts. Again, they produce these artifacts to bridge the landscape, the geography, to the consumers and the culture itself. In a way, they created the culture we see. By including artisans to the material science and technology discussion, we can better understand knowledge of the artisans, how the artifact production was linked to their landscape, and cultural choices in using these artifacts, and raw materials, and kind of that larger distribution as well. Yeah. So again, thank you for your time, and thank you for being here to kind of let me share my research. And if you have any questions, I would love to answer or discuss further.